All right, so if we look at the first question here, we're basically going to see that we have some sort of probability density function, and they basically want us to see what it's going to equal when we integrate from 0 to infinity. Now, basically, another way you can look at this is you know that r of t is equal to f prime of t. So when we take the integral from 0 to infinity of f prime of t dt, we know that this is just going to be f of infinity minus f of 0. And basically this is asking us what's the probability that one of the light bulbs will die from 0 to infinite time. And that's basically going to be 100% probability, so that's going to equal 1. All right, so for question 2, the main thing you want to understand about a probability density function is we kind of follow one key thing, and that's going to basically be the integral from a to b for f of x dx is going to equal 1. And basically this tells us that on its range of the probability density function, you're always going to have a probability of 100%, right? Because that's the maximum amount of probability that you can have for something to occur. So on its range, we want to make sure it's equal to 100%. Now that we see that the function is CE negative 8x when x is greater than 0, so basically this tells us that from 0 to infinity, CE to the power of negative 8x is going to equal, dx is basically going to equal 1, right? So if we do some integrations here, we're going to get CE to the negative 8x over 8, and that's going to be negative as well. And we know that this is going to be from 0 to infinity. So plugging that in, we're going to get, so e to the power of negative infinity, so we can do e to the negative infinity. This is basically going to become 0. So the first leading term is actually going to become 0. And we're going to get 0 minus, now we can do c e to the negative 8 times 0. And then this is all over negative 8. And we know that this whole thing has to equal 1. And what we're going to see is that we're basically going to see that e to the 0 is going to be just 1. So we have minus c over 8. So this means that c over 8 is equal to 1, and therefore c is equal to 8. All right, so starting on question 3, they want us to find the probability that x is between 3 and 9. So we can write this as p 3, 3 less than x less than 9. And we're going to have the equal signs because it's between those numbers. So another way of writing this is we're going to take the probability density function, which is in this case f of x. So we go from 3 to 9 for f of x dx. So basically we just have to integrate this along its range. But we'll see that it's actually going to be a piecewise function. So we're going to have to separate it into two in multiple different integrals. So we're going to multiply from, we're going to integrate from 3 to 6 because that's one of the first parts where the piecewise splits, and that's going to be from 2 over 1 over 2 x dx. And then we're going to add this with from 6 to the next number, which is going to be 9, and that's going to complete our range, right, from 3 to 9, and that's going to be 2 over 11 minus 2 over 187 x, and this is going to be dx as well. So for these kind of problems, they basically want to see that you understand, okay, a PDF is basically going to be representing the probability for a given range, right? So in this case, the range that they gave us, that x is between 3 and 9, is basically just going to be integrating the PDF from 3 to 9. So we get these two different sort of answers here. All right, so if you guys have taken a look at my Webwork trick study guide, we're going to see that there's actually going to be a kind of faster way to plug this into Webwork using some good bracketing techniques. But what you want to do is you basically want to factor out the constants first always. So that's going to be 2 over 102. And then at this point, now we know that this is going to be an x dx. So if you integrate x dx, it's going to become x squared over 2. So you're basically going to have some sort of bracket squared over 2 minus another bracket squared over 2. And then what we're going to do is we're just going to fill in the limits. In this case, it's going to be 6 and 3. And then we're going to add the next part, which is going to be 2 over 11. And then we're also going to add its limits, right? Because if you integrate some constant, it's just going to be x. So it's going to become 9 subtract 6. And then lastly, we're going to minus off the last part, which is going to be 2 over 187. And then again, it's going to be x squared over 2. So we're going to have some sort of thing squared over 2 minus some sort of thing squared over 2. And in this case, yeah, it's going to be 6 and 9. So we get 9 and we get 6. So you can actually use the shortcut key on your actual web work to type these kind of things in, which is actually going to save a lot of time. And the answer for this, by the way, you can plug this all straight into WebWork, so there's no reason you need to simplify it. You're basically going to get 213 divided by 374. Okay, so this question is basically going to be asking us for the mean. And what we know about the mean is that mean is equal to mu or x bar. And this is basically going to be integrating the PDF across its domain, so a to b, f of x dx, and there's going to be an x here. So in this case, the range is 0 to 9 pi. So we're going to be integrating from 0 to 9 pi, and we're going to throw in an x over 9 pi, and then we're going to have 1 minus cosine 4x dx. Okay, so what we're going to see here is that we can actually split this integral up in two parts due to linearity. So we actually have two sort of integrals here that we can use to solve. So if we just solve for the first part, what we're going to do is let's just factor out the 1 over 9 pi first. We're just going to see that we're going to be left with an x. Now, whenever you have an x, you're basically going to be left with something squared over 2. So if we plug that in, we're basically going to have something squared over 2 minus something squared over 2. So in this case, we're going to have 9 pi, and then we're going to have 0. Now, normally, if you have an actual number here, you don't have to simplify it. So in the web work, how you'd want to type it out is you would want to do your proper bracketing, so close first. 1 divided by 9 pi, and then what you could do is you could write it like this. So remember, this is a proper bracketing technique so that you can save time, and then you can just fill in your 9 pi, and then you can put in your 0 here. So remember to bracket properly if you want to make sure you're saving time for the actual WebWork exam. So these are just some good techniques that you guys can start working on. Okay, so if we look at the second part of the integral, we're actually going to be able to use a integration by parts to solve this. So what we're left with over here is just going to be minus 0 to 9 pi, and then we get 1 over 9 pi, and then x cosine 4x dx. So to solve something like this, I would use the DI method, or it's basically a shortcut to do integration by parts. So basically we're going to have our D column. If you don't know how to do this technique, by the way, I recommend searching it up. It's a very helpful way to integrate very quickly. Okay, so we have the DI method here, and what we're going to do is we're going to fill in our x for our differentiation and our cosine 4x for our integration. Now for the differentiation side, we get x1 x becomes 1, becomes 0, and then the integration, this becomes sine 4x over 4, and cosine negative 4x over 16. Now, if you guys are familiar with the DI method, you know this is going to be plus, minus, plus, and we're going to pair diagonally. So this is basically going to become, I'm going to factor out the 1 over 9 pi, and I'm going to plug in our thing. So we're going to get x sine 4x over 4, minus minus basically becomes plus cosine 4x over 16. And now this is on a range from 0 to 9 pi. Now, if you wanted to, you could plug this into your Webwork, and you could just let it solve it for you. So to plug this in a sort of strategic and smart way, what we would do is we would subtract 1 over 9 pi, and then what we would want to do here is we would want to write our actual expression, except we would want it within empty brackets. So we would have this term plus this term, which is going to be our x sine 4x, and that's going to basically become, let's write our x sine 4 over 4, and then this one is going to become cosine 4, sorry, it's not going to be an x, it's just going to be 4, and then this is going to be over 16. And then now what we want to do is we want to use this to copy and paste it. So, and the reason why we're going to copy and paste it is so that we can plug in the other limit. In this case, it's going to be 0, but remember, with trigonometric functions, you don't know whether the thing is going to equal 0 or some number. So in this case, we're going to have 4, and then this 4 is we're going to multiply by 9 pi first. And then again, for this one, we're going to multiply by 9 pi. And then we're subtracting off the lower limit, which is going to be 4 times 0, and again 4 times 0. So basically, this is what we're going to plug directly into the Webwork, which is going to save us a lot of time because we don't have to do any calculations at all. If you actually look at this, though, we're going to see that sine times sine of any multiple of pi is going to equal 0, and sine 0 is also going to equal 0. So this is actually going to become 0. And then cosine 36 pi is going to equal 1, and cosine 0 is also going to equal 1. So this is going to equal 0. So actually this whole term becomes redundant. So if you knew that, you didn't have to go through all that work. But remember that plugging in this whole expression will actually still give you the right answer. But yeah, it would be easier to just plug in this first part. And then if you did plug that into your Webwork, you would get, I think, this is equal to 14.137. All right, so for question 5, the question asks us, what is the probability that the customer will have to wait at least 6 minutes? So the probability that a customer waits at least 6 minutes is basically the probability, basically the probability of x between the time and infinity, right? Because it's basically when it's greater than 6 is at least. So we would basically be integrating the PDF from 6 to infinity in this case. So we go from 6 to infinity of 2e to the negative 2t dt. So in this case, what we're going to get is we get the integral. If we solve it, this one's not too bad of an integral. We basically just get 2e to the negative 2t over 2. And what we're going to see, over negative 2. And then we're going to integrate this from 6 to infinity. Now, one of the things we see is that e to the negative infinity is equal to 0. So we know that the first leading term is going to be 0. And then we're basically just going to be left with minus minus. So minus 2 over minus 2. E to the negative 2 times 6. So that's going to become 12. So basically this is just going to become e to the negative 12. Pretty simple one. So this is what we would plug in. All right, so for question 6, we're looking for the mean again. So just to reiterate, remember the mean is x bar, and it's going to be equal to the range x f of x dx, where f of x is going to be the PDF. So in this case, because we have a piecewise function, we're going to have to integrate over the range that they give us. So remember, we're going to have to multiply each term by x. So if we set up our integrals here, we're going to go from 0 to 15. And we're going to get 2 over 285 x squared, remember to multiply by x, and then plus 15 to 19, because that's going to be our whole range. And then we're going to have 2 over 4x minus 2 over 76 x squared dx. So this is, again, is one of those integrals that you can really kind of just do in your head, or not in your head, but you can just directly plug it into the Webwork. So we're going to start with the 2 over 285. Remember to always factor out your constants. And then here we want to start typing in our actual integrand part. And remember, it's going to be x squared. So when you integrate it, it becomes x cubed over 3. So we cube it over 3, and then minus, in this case, it's going to become 0. It's the lower limit, so it doesn't really matter. And what we're going to plug in is we're going to plug in 15. Now we just have to add the secondary part, which is going to be an addition sign, and then we're going to have 2 over 4. And then again, remember, this is an x, so it's going to become an x squared over 2 minus this squared over 2. And then we plug in our limits, upper limit 19, lower limit 15. Now, the last part is going to be another x squared, so we're going to minus 2 over 76, and then we're going to fill in our brackets. Remember to do good bracketing, and then we so we cube it over 3 minus cube it over 3, and then again we can plug in our limits, which is going to be 19 and 15. So if we just plug it in as is into the Webwork, the answer we're going to get is 34 over 4. So you might think that you want to plug it in all on paper and sort of do those algebraic sort of calculations, but the problem is you might make a mistake, which is why it's really powerful to use the Webwork to actually just plug in all of these numbers for you, and then you'll be able to get to the answer faster. All right, so for question 7, we'll see it's 2 parts. So for part 1, it's basically asking us, what is the probability that you dropped in within 1 kilometer of being home? So that's basically asking us that p of 0 less than or equal to x less than or equal to 1. So in this case, we're just going to integrate the probability density function from 0 to 1 for 2e to the negative 2x dx. Okay, so what we're going to see is that the integral of this function is basically going to be e to the negative 2x negative. All right, okay. And this is going to be evaluated from 0 to 1. So when we plug this in, we'll take the upper limit, so e to the e negative 2 minus minus, so that becomes plus e to the 0, which we know is going to equal 1. So this is basically going to equal 1 minus e to the negative 2. So yeah, there's nothing really special about this one. You can just plug it in as 1 minus e to the, don't forget your brackets, negative 2. Okay, so for part 2, this is basically telling us the probability. So it's saying that when we have the PDF and we go from 0 to y for 2e to the negative 2x dx, this is basically going to give us a probability of 0.95. And then we know from the last question that we're going to get our upper limit as minus, so we're going to kind of follow this pattern here, where we have 1 minus e to the negative 2y. And then that's basically going to tell us what our y is, because we can solve for this. So what we're going to do is we're going to move the e to the left side, and we're going to get e to the negative 2y is equal to 0.05. And then we're going to solve for y by taking ln of both sides. So we get negative 2y is equal to ln 0.05. And then lastly, we just need to divide both sides by negative 2. So we get ln 0.05 over negative 2. And then this is going to give us our answer. So let me just plug this in. Don't forget your brackets. Where we get 0.05, and then we get over a negative 2. So I'm pretty sure typing in like this works, but just maybe just put in brackets, just so you don't risk making a mistake here. Yeah, so that's how you do question 7. All right, so for the first part of this question, they want us to find the density function. And what we're going to see is that when you have the CDF, or the cumulative density function, when you take the derivative of it, basically this is going to give you the PDF. So in this case, we want to take the derivative of 1 minus 2r squared plus 2r plus 1 e to the negative 2r. So yeah, this is basically back to Calc 1, where we're just going to take a derivative. So we get 0 minus, and then this part we can actually use product rule. So derivative of the first times the second, etc., etc. So we're going to get 4r plus 2, and then times the second, which is e to the negative 2r, and then plus derivative of the second, which is going to be negative 2 e to the negative 2r, times the first, which is going to be 2r squared plus 2r plus 1. Okay, so at this point what we have to do is we just have to do some factoring and expanding. So what we're going to do is we can actually factor out the common e to the negative 2r term. So we'll take that out, and we get negative e to the negative 2r, and then we get 4r plus 2 plus, and then what we're going to do is we're actually going to apply the negative 2 inside. So we get negative 4r squared minus 4r minus 2. And what we're going to see here is that these 4r's will cancel, and this 2 will also cancel. So we're just left with negative 4r squared, and that's going to be multiplied by negative e times to the power of negative 2r. So this is just going to become 4r squared e to the negative 2r. Okay, so for part 2, we actually need to use this PDF part to find the mean distance. So what we can do here is we can just use this as our PDF. So what I'm going to do is I'm going to erase the other parts here. Give me a second. And then we're going to have to use an integration by parts technique to be able to solve the mean, because it's going to be pretty tricky. So we know that the PDF, or p of x, is equal to, I guess it's going to be p of r here. It's going to equal to 4r squared e to the negative 2r. So something that's important here is that we need to remember that the PDF works in a certain way, which is the mean, or mu, or x bar is basically going to equal the integral over its range, x f of x dx. So in this case, we're basically going to be integrating on our range, which is going to be from 0 to infinity, because that's the maximum range you can get away from an atom. And then instead of x, the variable we're using here is going to be r. So we get 4r cubed e to the negative 2r dr. Okay, so whenever you find a polynomial like this, which is going to terminate, what you can do is you can use the DI method. So the DI method is going to have derivatives and integrals, and we're basically going to want to put the derivative side on the side that's terminate, so r3, 3r squared, 6r, 6, and then 0, and then the integration side is going to be the e or the non-terminating side. So we get e to the negative 2r, e to the negative 2r over negative 2, e to the negative 2r over negative, it's going to be negative 2 times negative 2, so it's going to become 4. And then let me just clean this up a bit so it's easier to, e to the negative 2r over 2, e to the negative 2r, 4, e to the negative 2r over negative 8, and then the last line is going to be e to the negative 2r over 16. Okay, so, oh wait, it's a bit off screen there, give me a second. All right, so what you'll know about the DI method is we alternate between plus and minus. So we're going to have plus, minus, plus, minus, plus, and then we want to pair diagonally. And then that's basically going to give us our answer. So to plug this in, what we want to do is we want to write it in terms of, just basically pair up the terms together. So we get r cubed e to the negative 2r over negative 2. And then we want to add the minus sign. So we're going to minus 3r squared over 4. And then we add e to the negative 2r. And then again, we're going to have the other term, 6r times e to the negative 2r over negative 8. And then finally the last term, negative 6e to the negative 2r over 16. Now all of this, because earlier we factored out the 4, there's a 4 out here. So remember that this whole thing is going to be integrated from 0 to infinity. So what you're going to notice is that every single term has a e to the negative over there. So when we plug in infinity, all we're going to be left with is just going to be 0 and then minus this whole term. So 4, and then everything now we're going to plug in 0, and we know that e to the 0 is basically going to equal 1. And then because there's r's here as well, the first term, that's going to become 0. This term is going to become 0, plus, again, another r term, so it's going to become 0. And then finally, the last term, we get 6 e to the 0, so it's going to be 1, so over 16. And then this is basically going to give us negative 4 times negative 6 over 16, which is going to equal 6 over 4, which is equal to 3 over 2. And that's basically going to be our answer. All right, so for this is question 9, and what you're going to realize is that these kind of questions, you're going to repeatedly use the same sort of equation. So it's actually going to be really beneficial to just write out a general term, and then we're going to copy and paste that using our Webwork. So what I mean by that is, let's just first take the integral from a to b of p of x dx, and this is going to give us the integral for a to b for 0.5 e to the negative 0.5 x dx. Okay, so when we solve this, what we're actually going to see is we're going to be left with negative e to the negative 0.5 x from a to b. Okay, so what I mean by general term is that we know that whenever we go through between two limits, so a to b, this is always going to equal negative e to the negative 0.5 b minus minus, so it becomes plus e to the negative 0.5 a. So we know that for all these questions, we can actually use a blanket term, which is going to be 100, because we're finding the percentage, right? E to the negative 0.5 a minus e to the negative 0.5 b. Okay? So we're actually just going to copy and paste this and reuse this for all the questions that have the percentages. So that's going to be A, B, C. So when we write this out, we take 100, we multiply it by e to the negative some term, and then minus e to some term as well. Just remember which term is which. I'm going to put in my brackets. And then at this point, what I would do is I would fill in the negative 0.5 and negative 0.5. And then what I could do is I could actually copy this into my clipboard so that I could reuse it for the next few questions. So I'm going to paste these for the next few questions. And then for this question, it's between 3 and 4 minutes. So I'm going to plug in. Remember that because we switched the order of the limits, A is in front now. So the lesser number is going to be in front, so 3 to 4. And then for the next one, what we're going to see is that it's going to be between 3 minutes or less. So that's just going to be 0 to 3. So 0 to 3. And then for this next one, we're basically going to have from 3 to infinity. So we're going to fill in 3. And then we can't actually plug infinite into Webwork, but we know that e to the negative infinity is going to become 0. So we can just sort of back that up. And then those are going to be our 3 answers. For the last one, though, it's asking us for the cumulative distribution function. And we know that the cumulative distribution function is just going to be from 0 to x, p of x, dx. And now that we've already sort of established what the integral is equal to, we can reuse that. And it's just going to be e to the a first, which is going to be just e to the 0, so 1, minus e to the negative 0.5 x. So that's going to be our answer. We'll plug that in, e1 minus e to the negative 0.5 x. And then that's going to be the answers that we have. All right, so for this question, we have part A, which is to determine the value of c. So to figure out how we have a value of c, what we basically need to do is we just need to integrate again over its range for c cosine pi over 4 x dx. And remember that the when you integrate a PDF over its range, it's always going to equal 1. So that's kind of the hint they give us. And then what we're going to see is that when we integrate cosine, well, first of all, c is just going to be a constant, so we can take that out. Cosine, we're basically just going to get sine pi over 4 x. But then we have to remember chain rule. So this is going to be multiplied by 4 over pi. And then this is basically going to be over its range, so from 0 to 2. So what you're going to see here is that sine 0 is actually going to be just 0. So we only need to care about the 2. So we take c, and then sine pi over 4 times 2 is just going to be pi over 2, which gives us 1. So we get 4 over pi, and this is equal to 1, which basically means that c is equal to pi over 4. All right, so for part B, we're going to have the 0th moment, and the 0th moment is basically what we just calculated, so it's just going to equal 1. So I guess that's a bit of a red herring there. But when you find the 0th moment, it's just going to be integrating from a to b, so it's range p of x dx, right? Which is, we know, is going to equal 1, like we've just shown here. So this part is going to be equal to pi over 4, and this 0th moment is just going to equal 1. All right, let me just clear up this part first. All right, so for part C, they want us to find the first moment. And just a quick refresher, the first moment is just from a to b, x, p of x, dx. So this is just the mean, right, or the x bar. So in this case, this is going to be from 0 to 2, pi over 4, x cosine pi over 4, x dx. So for this kind of question, what I would do first is I would factor out the pi over 4, and then I would use integration by parts. Again, using the DI method, because that's what's going to save time. So we get a D and we get an I here. Again, we want to use the X on the D side, 1, 0. and then we get cosine pi over 4 x, then we get sine pi over 4 x multiplied by 4 over pi, and then lastly we get negative cosine pi over 4 x times 4 squared over pi squared. So at this point what we could do is we could actually write out our whole expression, and then we could plug in the limits to solve for our answer. But I prefer to actually type it into the Webwork because then you would make less arithmetic mistakes. So I'm going to go over how to do that after we put the terms together. So remember, it's going to be plus, minus, plus, and we pair it diagonally. So once we know that, we have the pi over 4 out front. So it's going to be pi over 4 multiplied by 4x over pi sine pi over 4x, and then we're going to minus minus, so that's going to become a plus 4 squared over pi squared cosine pi over 4x. Okay, so this is going to be our whole term, but it's going to be from 0 to 2. So at this point, what we need to do is we can either plug in our numbers or we can actually use the Webwork to our advantage. So how we can do that is we can plug in this whole expression as an empty expression, and then we'll plug in our terms. So what I mean by that is I'm going to type in pi over 4, so that's going to be the outsidemost term, and then I'm going to plug in brackets, and then because I have two terms, I'm going to set up those two empty brackets. So this represents the sine term, and this represents the cosine term. And then now I'm going to have 4x over pi, so it's going to be 4 blank over pi. And then I'm going to multiply this by, again, it's going to be a sine pi over 4. So I'll write sine pi over 4, and then again I'm going to multiply it by a blank because that's where the x is going to be. And then the next term is going to be the cosine, so it's going to be 4 squared divided by pi squared, and then I'm going to multiply it by a cosine, and then I'm going to have a pi over 4, and then again I'm going to multiply it by a blank, which is going to represent my x. So remember, all the blank spaces represent what x is equal to. So now what I want to do actually is I want to copy this entire expression, not including the pi over 4, right, because that's on the outside. And then I'm going to reuse it after I plug in the limit. So I know that this is the upper limit, so I plug in 2 here into basically where all the blank spots are. And then now what I'm going to do is I'm going to subtract an empty bracket and paste what I copied earlier. And then I'm going to plug in 0 for my blanks. So we'll see that there's actually going to be 3. And then I could actually plug this entire sort of bracket expression into Webwork, and it would give me the right answer. So yeah, that's how you would solve it using the Webwork. So for those of you who actually wanted to figure out what the algebraic expression for it was, when you end up plugging in everything, you're going to be left with 2 minus 4 over pi, which is equal to 0.726. Which if you actually plug in this entire expression to Webwork, you're going to get this as well. So it kind of just is a way to, because Webwork is a calculator, we can actually use it to solve our problems rather than having to algebraically plug it in. All right, so for part D and part E, it's basically, we're going to repeat the same process. So in part C, we showed that the first moment is basically going to be integrate over its range, x px dx. So for the second moment, it's going to be x squared px dx, and then lastly for the third moment, it's going to be x cubed px dx. So you would go through the same process, and then you would use integration by parts. Specifically, you'd probably use the DI method, and then you would plug everything in, and then you would get these answers. So just to save time, I have actually already searched up the answers for these ones. But going through the same process, you should be able to get the same answer. All right, so for question 11, it's asking us to find the constant a. So this is actually a really good pattern you can actually notice, is that when you integrate from 0 to infinity of some constant, let's call it a, e to the negative at dt, this is always going to equal 1, right? And from what we know about a PDF is that it should equal 1. So whenever you have this kind of question, 0 to infinity of some constant e to the negative 0.11t, 119t dt, this is basically going to equal 1. And it's basically telling us that a is equal to 0.119. Okay, so for part 2, there's actually a really sort of interesting feature, which is that when you integrate a e to the negative at dt, for example, you're just going to get negative e to the negative at. So this is kind of just a fact that you're going to run into, and it kind of just saves time because this is a common integral that you run into. So remember, for the CDF, we're basically going to integrate from 0 to x or 0 to t. So 0 to t, and in this case, it's going to be 0.119 e to the negative 0.119 t dt. Actually, I'm going to change the variables so that it's not confusing. So we use x, and then we know that this is going to equal negative e to the negative 0.119 x, and this is going to be evaluated from 0 to t. So what we'll see here is that, let me just move this over. So when we plug our limits in, we're going to get a negative e to the negative 0.119 t, and we're going to minus minus, so that becomes a plus. E to the 0 becomes 1. So this always kind of ends up giving you this pattern, which is going to be 1 minus e to the negative 0.119 t. Or if you want to remember it, you can always remember that 0 to t for a e to the negative at dt. Again, I'm going to change the variables so it's not confusing. X dx. Basically, this is always going to be 1 minus e to the negative at. So that's kind of a common pattern you can use. Oh wait, sorry, it's a bit off screen here. Yeah, so I was basically saying that whenever you integrate this, which is 0 to t of, this expression, which is 0 to t a e to the negative ax dx, you're always going to end up with 1 minus e to the negative at. So that's kind of a common pattern you can kind of memorize, because it normally does pop up on the exam. So that's how you do that one. All right, so for part 3, we see again that they want us to find the mean. And the mean is, again, to review, integrating over the domain x px dx, which is equal in this case from 0 to infinity, x times 0.119 e to the negative 0.119x dx. Okay, so I've kind of already started the integration by parts over here using the di method. So what you're going to see is that when we pair our terms together, don't forget this constant up front. So we have a 0.119, and then what we're going to see is we actually have a common e term. So I'm actually going to factor that out, and I'm going to get a e to the negative 0.119x. This is over 0.119, and then I'm going to multiply by x. And then there's actually going to be a negative sign, a negative x. And then this term is going to be minus, but remember that I'm subtracting, so it's going to be minus 1 over 0.119. And this is basically going to go from 0 to infinity. I'm a bit off screen here. So let me just put this here. Right, okay. So what we're going to see is that, well, first of all, these 0.119s cancel. And we're basically going to have a e to the negative something term. And when you plug in e to the negative something, even if you have it multiplied by a linear infinity, the e is going to win, right? Because e is stronger than x. So this basically means that this term is going to go to 0. So that being said, the infinity term doesn't actually give us anything. We're just going to get 0. So we're going to have 0 minus, and then we're going to plug in our term now, which is going to be e to the negative 0 multiplied by negative 1 over 0.119, like that. And then we're going to have this as equal to just 1 over 0.119. So here's another pattern too that you might be able to notice, is that whenever you integrate a function such that it's going to be 0 to infinity, x a e to the negative a t dt, for example. Oh, sorry, it's going to be x here. X dt. What we're actually going to get is this is always going to equal 1 over a. So that's a kind of cool little pattern you can use on your exam if you ever see this type of question. It's kind of like a quick little shortcut that you can use. All right, so for this question, question 12, there's 2 parts. It says, what type of function is shown in this graph? Is it a PDF or CDF? And the answer is a PDF, because a CDF is always increasing, right? So remember that when you integrate a PDF from 0 to t, let's say p of x dx, this is basically going to be our CDF, cumulative density function, t. And it's basically going to tell us the probability from 0 to t of the probability of the thing occurring within that range. So the probability is always going to keep increasing as we increase our number, right? So this basically means that the CDF is always going to be increasing. And because this function decreases, it can only be a PDF, not a CDF. So the answer is going to be a PDF. Okay, and then for the second part, what we're going to see is that we know that the area of under a PDF on its range is always going to equal 1. So that's kind of the giveaway here. So we see that 4c times 0.5 plus c times 0.5, this is basically going to equal 1. So what we get is we're going to get, we'll factor out the 0.5, and then we basically get 4c plus c, which is 5c. So we get c is equal to 2 over 5. Oh wait, I just realized I covered up the answer here. Let me just. Okay. So yeah, like I was saying, you're basically just going to take that range to form a sort of rectangle, and then you can multiply it, and then you'll get 0.042. So for part B, this question is saying, would you expect P74 to be greater than P69? So we would basically expect B. P74 is less than P69 because it's less likely to find somebody who's 74 inches, somebody who's taller, right? It's more likely that you'll find somebody who's shorter than that. So that's why we would say B. Okay, so for part C, if it says that pH is a cumulative distribution of the function p, this is basically means that the area is going to be equal to 0.5. So if we integrate from 0 to h for p of x dx, this is basically going to equal 0.5. Another way of saying that is that the big P of 69 is going to equal 0.5. Sorry, in this case, h is equal to 69. Okay, so now that we know that, we basically want to figure out estimate what P of 68.9 is equal to. So from what we know about integrals, right? When we have an integral from a to b, you can essentially split this integral up as equal from a to c plus from an integral from c to b, where c is basically between a and b, right? So what we're going to do here is we're going to take this sort of concept and we're going to use it for the PF. So what we'll see is that we have one part which is going to go from 0 to 69 for our P of x dx. And we can actually say that this is going to be equal to some other value, which is going to be from 0 to 68.9 plus 68.9 to 69. And then I've kind of just left the integrands part blank. So now basically what they're asking us for is they're asking us for big P of 68.9, which is just going to be this. So we can actually solve, and we get 0 to 69, subtract 68.9, 69, and this is basically going to equal P of 68.9. Again, this is an approximation, so it's not an equal. And what we're going to get is we know that 0 to 69, we just solved it from earlier, or sorry, they gave it to us, is going to be 0.5. And then from here, we want to figure out what 68.9 to 69 is. So we can approximate that using the height that was given, which was 0.21. So we get 0.21, and then we have 69 minus 68.9. So if you're wondering, okay, why are we taking 0.21? So remember from the previous question when we found the range, we're using an approximation. So we take the height of one of the values, which is 69, and we know that that's equal to 0.21. So we kind of assume that 68.9 is around the same place. So to figure out this range, we just take length times height, which is, here's our length and this is our height, and then that's going to give us a rectangle. So when we plug all that in, we should get our answer. Give me a second here. And I get 0.479. So yeah, you can repeat the same process for the 68.8 part, and you will get for the other part as 0.458. So this will be P of 68.8. And basically what we're going to do here is we're just going to write those in. And then those are our answers. All right, so for question 14, we'll look at part A, and it says that we want the proportion of students who take between 1.5 and 2 hours to finish the exam. So that's just going to be P of 1.5 less than X less than 2. So that means we're just going to be integrating from 1.5 to 2. And it's going to be 3x squared over 8 dx. So again, this is something that you can really easily plug into Webwork. So I'll demonstrate this in the text box. So we type in 3 over 8. Always factor out the constant first. And because it's x squared, it's going to be something cubed over 3 minus something cubed over 3. And then we know that the upper limit here is going to be 2, and the lower limit is going to be 1.5. Again, we can just leave it in that form because it's going to be easier for us to do. And then for part B, they want us to find the mean. Again, we're just going to do a quick review. The mean is just over a to b, x, p of x dx. So in this case, we just add one x to the term. Again, this is a very simple integral that we can plug into Webworks. We get 3 over 8, and then we type in our brackets, and then here, because it's x cubed, it's going to be something to the power of 4 over 4 minus something to the power of 4 over 4. And again, we're going to plug in our upper limit, and then we're going to plug in our lower limit. And then again, this is ready for Webwork to answer for us, so we don't have to simplify anymore after that. So at this point, we have part C, and part C is basically asking us for the median. So remember that the median, we're just going to integrate from 0 to t, and then it's going to equal to 1/2. So I've already started on this integration, and I get 3t to the power of 4 over 24. And if I solve this, I'm going to get 12. So t to the 4 is equal to 4. And then t is equal 4 to the power of 1/4. So again, we could plug this into, oh, sorry, let me just, it's kind of clashing with the logo there. So t is equal to 4 to the power of 1/4. So yeah, we can just plug this directly into Webwork, and it will give us the right answer. Keep going off screen here. T is equal to 4 to the 1/4. Okay, you still can't see that. Okay, like that. All right, so for part 15, we're gonna have, we want to come up with a survival function, which basically tells us that they survive t or more years. So remember, at least is the same thing as saying t or more. So we're basically going to integrate from t to infinity of our function, ce to the negative ct. Yeah, I'm going to change the variable so it's not confusing. And basically what we're going to be left with is 0 minus e to the negative cx. Sorry, I missed my sign here. Minus, so this is basically going to be e to the negative cx. So for part B, we want the patient having a 60% chance of surviving at least 2 years. So their survival is going to be 2 years, right? Or it's going to be from 2 to infinity of our function. So in this case, we know that x is equal to 2. So we have e to the negative c times 2. And then what we actually have to do is we have to solve for the other side, which is going to be equal to 60%. So this is 0.6. Because they gave it in the question. So at this point, what we have to do is we have to take the ln of both sides. So we get ln 0.6 is equal to negative 2c. So c is equal to ln 0.6 over negative 2c. Sorry, just over negative 2. And then that's going to be our answer for the part B. All right, so for part C, what we're going to notice is that we're integrating ce to the negative ct. So if you guys remember, there's a pattern, which is when you go from 0 to a e to the negative a t dt, this is basically going to equal 1 minus e to the negative a, I'm going to change this to x. Right, so that's like a little common pattern you can use. So what you're going to notice is that in this case, our x value is actually going to be equal to, probability is equal 1 year or less. So it's going to be just a 1. So we're actually going to have 1 minus e to the negative a. A in this case is just going to be the c value. And then x is going to be equal to 1. So it's just going to equal 1 minus e to the negative c. And then again, because of Webwork, you don't have to simplify, you can just plug it in. So we're going to do 1 minus e to the power of, we're going to put brackets, and then because we have just one thing here, we can just type it out, which is going to be ln 0.6 divided by negative 2. All right, so this is question 16, and again, it's going to be the same question as earlier. We know that it's going to be a PDF. Why? Because it doesn't constantly increase. It starts to decrease, so therefore it needs to be a PDF. And again, we know that the area for its range, it has to be equal to 1, and we see it's a triangle, so we'll take c times 5 divided by 2 is equal to 1. So we will plug it in, and we'll see that c is equal to 2 over 5. So that's going to be the answer for that one. All right, so for question 17, we're going to see that they're asking for the PDF again. So when we sort of asking for the value c, so we know that c is constant, so we can factor the c out, and then we can integrate, and then we can plug in our values. And what we're going to get is equal to 1. So when we divide this, we get c is equal to 1 over this whole thing, which is basically equal to 3 over 500. And then for part 17, sorry, not part 17, we have the other part. We're going to see that between 0, below 0 is going to be just 0 because the probability is going to be 0. There's no sort of, the PDF is not defined there. When it's greater than 10, it's always going to be 1 because the maximum probability after is just going to be, in total, it's going to be 1. And then the PDF between 0 and 2, well, that's just going to be from 0 to x of c, so 3 over 500 times 10x minus x squared dx. Oops, sorry, that's a bit off screen. There we go. So if you plug this in, what we're going to get, oh sorry, let me just change this x so it's not confusing. So we can go to 0 to t instead. We'll factor out the 3 over 500. And then we're going to have the 10x part, so that's just going to become 10t squared over 2. And then this is going to minus t cubed over 3. And then this is basically going to be our answer for over here. Again, we have to change the x, the t's to x's because it's in terms of x, but that'll give us the right answer. All right, for question 18, we're going to have the first part, which is px greater than 32. So that's just basically saying the probability of 32 to infinity, which is what we get here. And when we integrate it, we get negative 9 over x. We plug in infinity, we get 0, and we plug in 32, so we get negative 9 over 32, which is equal to 9 over 32. So this first part is 9 over 32. And then we get the next part, which is the CDF. So we're going to integrate from 9 to x for 9 over t squared dt. I changed the variable so it doesn't get confusing. And then you get negative 9 over x, and then 9 over 9, which is just 1 minus 9 over x. So this becomes 1 minus 9 over x. Okay, so for question 19, it's asking us, part A, it's asking us, what is the probability that a butterfly will die within 6 days of emerging? So what we can do is we can figure out the probability that it will live more than 6 days, and then we can subtract that from 1. So we know that the probability of 1 minus die within 6 is equal to survives more than 6. So if we kind of use this algebraic expression, we can do 1 minus survive 6, and this is equal to die within 6. So all we have to do here is we just have to, the probability it's going to survive within 6 days is just going to be p t greater than 6, which is equal to 36 over 6 plus 6 squared, which is equal to 1 in this case. So it's going to be 1 minus 1. So the probability of it dying within 6 days is actually going to be 0%. 0%. Okay, so for part B, it's asking us, if a large number of butterflies emerge on the same day, after how many days would you expect only 6% to be alive? So we know that P of t greater than t is going to equal 0.06, which is 6%. So all we have to do here is we just have to solve for t. So we get 36 over 6 plus t squared equals 0.06. And then when we solve for this, we're going to get t is equal to 36 over 0.06 minus 6. So I'm going to plug that into a calculator. And I get 18.49, which is going to be the amount of days you would expect only 6% to be alive. All right, so for part C, we're going to see that we need to find the PDF. And to find the PDF first, we need to make sure that this is a CDF. So we're going to have 1 minus 36 over 6 plus t squared. And the reason why we have that is because we're going to have when t is basically going to be 0, right? And t is basically going to be 0 when you plug in 0 here and you get 6 squared, so 36 over 6 squared, and that's equal to 1. So when we take the derivative now, we're going to get positive 72 over 6 plus t cubed. So remember, to find the mean, we're just going to multiply it by x px dx. So in this case, it's going to be t. And we're going to be left with the integral of this. Now to solve the integral, what we need to do is we need to do some u subs. So we're going to do u is equal to 6 plus t, meaning that du is equal to dt, and t is equal to u minus 6. We get over here, and what we're going to do is we're going to separate it into two different integrals using linearity. So we separate it here, and then after we solve our integrals, we have it in terms of u. We need to plug back in the 6 plus t. After we plug in the 6 plus t, we're going to get over here, and we have this, and then it should equal 6, which is our answer. Okay, for question 20, again, they're telling us it's a PDF, so we know that the integral over its range is going to equal to 1. So we're going from 0 to 2, cx10 dx is equal to 1. Another way of writing this is we're saying that c from, and then we can just do the integral kind of in our head here, because it's x to the power of 10, we know it's going to be to the power of 11 over 11. It's going to be 2 to the power of 11 over 11, and then subtract off 0, so this is equal to 1. And then what? So we're going to get c is equal to 1 times 11, and then this is over 2 to the power of 11. So c is going to be equal to 11 over 2 to the power of 11. So it's asking for the first moment of f of x. So remember, for the first moment, all we have to do is we have to add another x. So we're going to take, again, we can factor out the c because it's a constant. It's 2 over 11, and then we get x times x to the power of 10 dx, and then we go from 0 to 2. and then again it's going to be x to 11, so this time it's going to be x to the 12. So we get 11 over 2 to the power of 11, and then we take 2 to the power, because it's 11, it's going to be 12 over 2, 12 over 12, and then minus 0. So that's going to be the answer for the first moment. It's a bit off screen here. Let me just... Okay. So that's going to be A. And then the second moment. We're basically just going to add another x. So we're going to add 11 over 2 to the power of 11. And then it's going to be 2 to the power of, instead of 12 now, it's just going to be 13 over 13. So you can kind of see that there's going to be a pattern developing here. And we're basically going to have it as the nth moment is going to end up being some value of n greater than 1. So it's going to be 11 over 2 to the 11, that's constant. And then we're going to have a 2 to the power of, in this case, it's going to be 10 plus n, 11 plus n. And then this is going to be over 11 plus n. Right, and the reason being is because this is the first moment, and this is the second moment. So we say 11 plus 1 is equal to 12, and 11 plus 2 is equal to 13. So we can kind of see here that we have this pattern, which will tell us what the function is going to equal. All right, so for question 21, we run into that function a e to the negative at again. So there are some common patterns you might want to learn about this function, because it does come up a lot on exams and Webworks. So the first one is it's when you integrate from x to infinity, a e to the negative at dt, we end up with e to the negative ax. When we integrate at e to the negative at dt, it's 1 over a, so this is basically the mean. And then when we integrate, or the first moment, and then when we integrate at squared e to the negative at, we get 2 over a squared, which is the second moment. Now in this question, we want to find the variance. So we see that the variance is equal to m2 minus mu squared. We have m2 over here, and then we have the mu, which is going to be 1 over a squared, because it's mu squared, and then we're left with 1 over a squared. So with that being said, we can actually answer all parts of the question now. So the first part, we have at least 6 minutes, so that's just going to be from 6 to infinity. So from the first equation, we can just use e to the ax. So a is in this case going to be 2, and then x is going to be 6. So it's e to the negative 12. And then in the next question, we have a is basically equal to 2 in this question. So a is going to be 1 over 2, and then b, we have mu, the variance is equal to 1 over a squared, so it's equal to 1 over 4. All right, so this is the last question for the Webwork. So why don't we go through them? So we have part A, which says, which PDF has the largest mean? So just looking at it, we're going to see that it's going to be B. And the reason for that is because if you take a look at where the PDF is weighted, right, all of the area is over here. So this means that the mean is closer to this side. Over here we can see that the mean is over here. And over here we can see that the mean is probably more over here because more of the weight is shifted to this side. So the largest mean is B, which is going to be to the right, you can see. Which PDF has the smallest median? Okay, so remember what represents the median? This is the point where half of the area is. So we'll see that half of the area for A is probably over here, where here is half of the area. So the median would be here, median would be here, and the median would be here. So we can see that this has the smallest median because it's the closest to the left. So that would be A. And then the last question is basically saying, which of the following is true? Var x denotes the variance in the graph panel. So if we look at the different options, let's take it out. We want to see which one is the most spread out, right? Which values have the most variance, which basically means the most spread out, right? So another way of thinking of it is we can look at sort of where the values lie. So if we look at C, C is pretty spread out, right? And if we compare with B, B is a lot tighter in. So we could say that the variance of B is less than the variance of C. So that would probably be C there. The variance of B equals the variance of C, that doesn't make any sense. And the variance of B being greater than the variance of C, that doesn't make sense either. So this is the only correct answer. And yeah, so that's going to be concluding Webwork 8.